Welcome to Miss Lisa's YouTube channel of all things math and science. Not really all things, but a lot of high school math and science. So this is classes physical science. It's designed primarily for homeschoolers, but if you like the way I explain things, you are welcome to be here. We are talking out of this book, which is Glencoe Physical Science. We are learning about energy today. So we're going to talk about what is energy. Energy is a hard thing to describe. It's one of those things you know what it is, but then when you start to put it in words, you're like, this is a little difficult. I'm going to give you an unsatisfactory definition, and then we're going to talk about it, and it'll make more sense as we go along. Okay, so according to your book, energy is the ability to cause change. Not that it's causing change, but it has the ability to cause change. It'll make more sense as we talk about it. But so there are different forms of energy. And once you start talking about that, you're like, oh yeah, I do know what this is. There is energy of motion, kinetic energy. There is potential energy, stored energy. Like the classic example is if there's a boulder on a hill, that it has lots of potential, because if it starts falling, then it is going to cause change if it hits you. You can have chemical energy that is stored in batteries or a chemical like gasoline. You can have electrical energy that causes motion of electrons. So as the electrons flow. And then there's radiant energy, which is what the sun is giving off, and thermal energy, heat energy. So we're going to talk about all of those and sort of how they interact together. Your book uses an analogy, and it says that energy is like money. That money, you could have money that's dollar bills, you could have gold that is valuable, you could have your ATM card, electronic money, but it's all money and it can all be changed from one form to the other. So you could, take your cash and go buy gold, or you could take your ATM card and go buy gold, or you could take gold and sell it and then use that to go buy some euros or whatever you want to do with your money. But it's all money. It can all spend. It can all cause change, but that it's in different forms. Okay, so I'm going to do this class a little bit different. The way I've been doing it is I teach one video a week where we do a chapter, and I have decided that I'm going to do it a little bit more like our math classes. If you've had me for Algebra 1 or Algebra 2, you know that I make a separate video that are the calculator videos for learning how to use your calculator to do the math. And in those videos, I'm zoomed up right on the calculator. It's all you can see. And I've decided that we need calculator videos for this class too, where we're going to go through. So I'm going to talk about the math a little bit in the video, but you're going to have a second video to watch every week, especially on the weeks when we're doing math, the more math part, the more physics part, and some of the chemistry, but mostly the physics of physical science. For those weeks, you will have a separate video. You're going to have a calculator lab video, so you need to have a scientific calculator. I will be using a TI-84 graphing calculator, which is the best. That's what you need to get if you can get it, but the one I have is $130. So I know that doesn't always fit into the homeschool budget for the year, but you can get them used sometimes. In fact, I got one for sale right now used. If somebody's interested who knows me, you can message me, because I've got one for sale right now. But anyway, you can get them used, but beware buying them used, because sometimes they're broken where you don't realize it right at first. You can do like 2 + 2, but then when you go in to start, really doing programs, they don't work. So anyway, if you can get one, it's the best calculator. The reason why is because it's the one that's used in college. It's used on the SAT and on the ACT. It is the one the colleges have decided that this one does enough and not too much. There are calculators out there that do more, but the colleges don't let you use them because they do too much. So this is the one. It is old, it is not intuitive, and that's why it's good to go ahead and get it in high school and start learning how to use it. Because the more you use it, then the better you get at it, the better you get at that calculator, the better grades you make in college, science and math. I tutor college also, not just high school, but I only do that 101. I don't make YouTube videos for it. Sorry, had to have a little coffee. This is my afternoon. Been teaching all day. I need a little coffee to teach 3 more classes today. All right, so we talked about one of the kinds of energy is energy of motion. It is called kinetic energy. Kinetic means motion. And there's another kind of energy called potential energy. And those two are kind of two sides of the same coin that you can convert from one to another. And together, is this where it talks about this? Okay, so there is a equation for kinetic energy. Kinetic energy is 1/2 mv squared, which is the mass times the speed squared multiplied by 1/2. So I will do in the math lab, I will show you how to go through and do those problems. So anytime something is moving, it has kinetic energy. Potential energy is stored energy. It has that potential. And there's different ways you can store energy. It can be a position. Say it's up very high and it could fall. It would have gravitational potential energy because it could fall. You could also have elastic potential energy. Like if I take a rubber band and wrap it around my hand, then I can fire it at you, but before I fire it, that rubber band is all stretched out and it has that potential energy. Also a spring, we can store energy into a spring. Sometimes you pull them out, sometimes you squish them to store the energy. But that's another way of storing energy in a spring. Another way of storing energy is in chemicals. In the chemical bonds that hold the atoms together, it takes energy to form them, and energy is released when they're broken. So chemicals are a way of storing energy. The plants take the sun energy, radiant energy, and form it through the chlorophyll in the chloroplast. They are able to take that sun energy and turn it into sugar. And then they use the sugar for energy. We use the sugar for energy when we eat plants, or another animal might use the sugar for energy, and then we eat them. If you're not a vegetarian, if you eat chicken, then the plant makes the chicken feed, the chicken eats the feed, and we eat the chicken in the South, especially fried chicken. So that is a way of energy being stored in chemicals. So today you ate breakfast, hopefully, and now that energy, that stored chemical energy, is being broken down by your body and stored into molecules like fat and other molecules like ATP and ADP and all of that you learned about in biology class, or you will learn about in biology class. But there are chemicals that store energy so that then your body can use it when it needs it. So also, there is a formula for gravitational potential energy, and we will do that in the math video also. So, energy can get changed from one form to another. I always tell the story of when I was in college, I was a cheerleader, and I was a basketball cheerleader for Erskine College. Yay! Go Flying Fleet! Yes, that is what we were. The weirdest mascot, except Presbyterian College, they were the Blue Hose. That seemed a little weirder. But anyway, I was a cheerleader. And one time, all the cheerleaders, and my college would do what was called 414, which meant we went for a semester, and then in the fall, and we went for a semester in the spring. But in January, you just took one class, and you got credit for a full class, but you only took one class, and they were weird things, and it was to make you a more well-rounded person. So one year I took Chinese, and I learned how to say wa ni. I'm sure I said that in perfect Chinese. I think it's I love you in Chinese. But I had a great teacher. We made real Chinese food from our Chinese teachers, and it was really interesting. I didn't do very good. It was Mandarin is what we tried to learn. And then one year I did German for travelers. I like the languages, so I learned about brat and how to say other travel-y things in German, and that one was real fun. And my professor was from Germany, so that was really interesting. And then one year I worked in a hospital. I worked in a hospital lab, so that was interesting, and I've used those experiences a lot as a science teacher. but I didn't like working in the lab. I thought it was kind of boring because I like people interaction, and I was just, quiet in the lab with my test tubes running tests and stuff. So I thought my favorite part of that job was when we would get there real early in the morning, because you have to run all the tests before the doctors get there to look at them. So we had to be there at 5 to start getting, people's blood and stuff, and then doing tests on them. But then at 9 o'clock, all the doctors had to have their tests in by 8, and at 9 o'clock we'd all go down to the cafeteria and eat breakfast together. And breakfast was my favorite part of that job, and I thought, I need to do something different if breakfast is my favorite part of this job. So I didn't stick with being a med tech. So then my 4th year, all the cheerleaders said that there was a class offered by the ROTC, and you didn't have to join the Army, and you would learn to rappel, which, jumping out of things with ropes on. You would learn to hike. You would learn to snow ski, and you would learn to scuba dive. We were going to the Florida Keys, and we were going to go learn to, and I'm open water PADI certified. But so we went we were going to do this. And the little icing on the cake was, we will be, because it was in January, we'll go to the Keys and we will get a tan in January when no one else has a tan. See, I told you it was the cheerleaders. So it cost money to do all these things, like extra money. So that's what I asked for from my parents for Christmas that year, and they gave it to me. And so I'm so excited, and I go to the first day of class, and my very good friend, Karen, she's Dooley now, she was Karen Russ then, came. And it was the first day of class, and none of the cheerleaders were there. But my friend who was visiting college went to class with me, and they let her do it too. And we rappelled out of the equivalent of about a 4 or 5 story building. It was a building with very high ceilings, and so it was about a 4 or 5 story building. And we jumped out the window on the ropes and went down, and it was so fun. But none of the cheerleaders were there. So I went to lunch that day, and to where all the other cheerleaders were, and I was like, "Where were you?" I was in the class. None of y'all were there. It was great. We went out the window. We went rappelling, and they said, "Oh, we chickened out because it was in the Army," and so we all decided to take knitting with Mrs. Dr. Thomas. So she was from England, and she was really good at knitting. A lot of people in England seem to know a lot about knitting. I guess it's the wool or something. I don't know. But anyway, Mrs. Dr. Thomas taught. So all the cheerleaders had chickened out, and they signed up for knitting instead. And they were like, we didn't tell you? We thought we told everyone. And I was like, no, you didn't tell me. But it was so fun jumping out the window with my friend Karen that I decided to stick it out. So I was the only one. Well, one of the things we did was we went snow skiing. And so it was the Army, so they didn't pay for anything fancy like snow skiing classes. It was like, here are your skis, here's your lift pass, there's a mountain, figure it out. Well, most of the guys, everybody in this class were very big and strong and physical. And even though I was an athlete as a cheerleader, I was the wimp. And people didn't really want for me to slow them down. The reason why you took this class is because you wanted to do these extremely adventuresome things, and no one wanted to slow down for me. And like, they knew how to ski, and I didn't know how. I knew how to water ski, but I didn't know how to snow ski. So I had my things, and I went over, and they said, start on the bunny hill. So you go over to the bunny hill. It was me and all these little kids, and you learn how to put your skis together. It's called the snow plow. You go, and you stop. And there was also a little rope, and you'd hold on to it, and it would drag you up to the top of the hill. So I got very good at the bunny hill, and I'm all by myself, and I think I'm ready to go do the lowest regular hill. So I go, and I go over to the ski lift, and I think, okay, I figured this out. And I go and I stand there, and you stand there, and then the little seat comes along and it scoops you up. So I see how everybody's doing. I'm like, okay, I can do this. And so I get there, and the seat comes along and it scoops me up, and I'm riding up. And I know that I'm supposed to get off on the first stop, but the thing is it doesn't stop. What you're supposed to do is jump off of the ski lift, fly through the air, land, and then ski over to where you go while this thing is continuously moving. Well, the bunny hill did not prepare me for that. So I was there, and like, I was like, okay, I gotta jump. And I didn't jump. I just sat there. And so I thought, okay, I'll do it on the next one. I can do it. And it was an even bigger jump where you'd go flying through the air before you hit the bottom. And then there was another layer. And then finally it was the tippy top of the mountain. And there it turns around. So you could just put your skis on the ground, no jumping involved, and stand up. So I did. I thought it was like Six Flags. I didn't know I could have ridden back down to the bottom. But I thought it was like Six Flags. You get to the end of the roller coaster, you got to get off. So I got off. It was the end of the line. I stood up. I thought, oh no, I have a problem. I'm at the top of a mountain and I don't know how to ski. And so the problem was I had too much potential energy. I had way too much potential energy for my level of skill. So, but up there are these little bitty kids and they are just skiing great. And I'm like, if little kids can figure this out, I can figure this out. So, and also I know how water ski. I'm like, how different can it be? I can even ski on one ski, water skiing. I can slalom. So I thought, I'll figure it out. So I watched the kids, and what they did, they didn't just go straight down the mountain, and the grown-ups, they would go back and forth in a zigzag pattern. So I thought, okay, I can do this. So I skied one way, and to turn around, you have to kind of like push down with one foot and hop and get going the other way. So I did it, and I did great, and then I did it again, and I thought, okay, this is going to work out. I'm going to be able to get off the mountain. Well, on the third time, I got cocky. You know, pride comes before a fall. I got cocky because I didn't push hard enough to get my skis turned around, and suddenly they were pointing straight down the mountain, and I thought, oh no, and very quickly I started going very fast, and I couldn't get my skis to go over that way, and I thought, okay, it's okay, I'll just get down real low and fall over, and I'll just crash. Well, so I tucked my poles under my arms and I got down low to fall over, but boo, I started rocketing like a bullet, and I started going so fast that I was already down to the next level, and there were lots more people in the next level from the very tippy top of the mountain, and I was like, oh no. So I stood up, and that did slow me down. I stood up a little bit, and I thought, oh no. And I thought, what am I going to do? And I hesitated, but I knew enough from water skiing to kind of, shift my weight, and I could steer a little bit. So I kept avoiding people so I didn't hit them and kill them. Meanwhile, I'm going faster and faster and faster. And I thought, okay, this is what I got to do. New plan. I will just crash. I'm sure I'll get a broken leg or something because I'm going 1 billion miles an hour at this point. I'll just crash and I'll just take myself out. That, I just have to make myself do it. Boom, I'm going to crash. Well, by this time I was at the next level down, and there were so many people that I knew when I crashed, I was not going to just take myself out. Someone else was going with me. There were too many people. So I am praying out loud, oh, Jesus, help, help, help. That person looks too nice to kill. I can't do that. And so I knew if I hit anybody, they were going to die. I was the bullet. They were going to be the target. They were going to die. And all of them looked so nice that they could not die that day. So I had a new plan. I'm bulleting down the mountain, straight down, with poles under my arms, avoiding people. And I thought, I know, there's a ski lodge at the bottom. I'll just make it to the bottom. It's made out of rocks. I'll smash myself against the ski lodge. That way I am the only person that will die. Good plan. So, all right. So all I have to do is avoid all these nice looking people all the way down the mountain. So here I go. Down, down, down. Now, let's talk about energy, what's going on. As I am going down the mountain, my potential energy is decreasing. So that was good. But all the potential energy that was there is getting turned into kinetic energy because I'm going faster and faster and faster and faster. And I want this energy to all be over. So the plan is smash into the cute little rock ski lodge at the bottom. While I'm up there messing around on the mountain, a line has formed in front of the ski lodge of people all lined up to get on the ski lift. I see them and it's like, no, I can't take out any of you. What am I going to do? So then I saw over on the other side another mountain. I thought, that's what I'll do. I'll just aim for that other mountain, and that rise will slow me down as my too much kinetic energy will get converted into potential. I didn't think that because I wasn't thinking about this lesson at that time. And I will stop. And I thought that would just take maybe 20 feet of heading toward the other mountain. So I lean lean toward the other mountain and go over that way. And but I was going so fast. I mean, I kid you not. I think I might have set an Olympic record. I was going so fast that I skied all the way up to the tippy top of the other mountain. And so all these other people are skiing down, and I am avoiding them as I'm skiing up, still at 1 billion miles an hour. I could not even stop as I'm going up the other mountain. I get to the other mountain, and I'm still going on the very top extremely fast. But they had this net up there to stop the snow from blowing off the mountain. So I crashed into that, boom. And then I crashed into the ground, boom. And I'm breathing so hard. This is great. I'm alive. All the other people are alive. But I cannot speak. I'm breathing so hard. Well, up comes the ski patrol. They're like policemen for skiers. They wear all black, and they came up and they let me know that they were mad at me by their skis. They went, made their skis all mad, and they started yelling at me. We saw what you did, and if you do that again, we are taking your lift pass. I'm like, really? You really saw what I did? Because if you did, you should absolutely take my lift pass right now. But I couldn't say it. I could not get a word out. I'm just breathing. So exhausted. So and then I thought, it's okay, I'll get help from them, because you realize I'm on top of another mountain and I still don't know how to ski. But I thought, okay, they'll help me. No, they all just yelled at me and skied off. And I thought, what am I going to do? Well, up skied the guys in the class. The class was mostly guys. There were a few girls, but it was just mostly guys who signed up for this adventure class. And they skied up to me and they said, Lisa, we saw what you did. That was amazing. We didn't know you can ski like that. And I'm going, I can't. I don't know how to ski. And they're like, what? I don't know how to ski. I just got going down the mountain the wrong way. I couldn't get off the ski lift. And they just started laughing, and they were like, oh, don't worry about that. When you're ready to do it again, we'll go with you. So they did, and they like each grabbed me on one edge. And when it was time to jump off the ski lift, they drugged me off and made me jump off of it. And then, so eventually I got where I could do the ski lift, thanks to them. But the guys, after they were like, oh, don't worry about it, we'll take care of you, they skied off, because I had to sit there and recover for quite a long time. And then I thought, why did I let them leave? I am still on top of a mountain, and I still don't know how to ski. So then I had finally a good idea. I took my skis off. I put them over my shoulder. I did not stand up. I crawled on my hands and knees over to the tree line, and I would hold one pine tree, and then I would crawl on my hands and knees to the next one, and then I'd crawl to the next one, all the way down the mountain until I made it down. And then I really had to think about if I was going to try it again. But we had a whole week at that ski resort. So eventually I did get where I could ski down. I learned how to turn and all that, and it was really fun. But I knew not to go to the very tippy top. I knew nothing about skiing. And there is this thing that is a black diamond, and that means this is a really intense course. And I knew that was at the very top, but I didn't know what it meant. So on the middle, there was one course that I'd gotten real good at going one way, and there was another course the other way. Well, it was a black diamond course. I didn't know what it was. So I just started skiing down it, thinking this will be fun, and it was jumps. I'm flying through the air. Ah, boom. Going through the air again. Ah, boom. And I don't know how you're supposed to do this, because, as you know, I don't know how to ski. Somehow the thing turned, but I kept going straight. I went into the trees. I grabbed the top of a pine tree, and then I'm going like both ways like this, shaking snow everywhere. I climbed down the tree, took off my skis, and crawled down, because I learned, take the skis off, if you get stuck. So anyway, there's something called bogles, something. They're like these series of jumps. I did that too without meaning to. I successfully did a little jumping, but then I ended up in a tree, so I don't know. Anyway, so my problem was kinetic and potential. And as you can tell from my story, that kinetic and potential energy can be changed one to the other. So here I have something that is a cute little thing of a dog, and showing what happens with energy for what is called parabolic motion. See, this shape is a parabola, and this dog is running along, and you can see that we're throwing its ball. Okay, so it starts off here, and the ball is still to start off with, but then then I throw it, and it leaves my hand going very fast, so it has a lot of kinetic energy, and it goes up, 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 up. But as it's going up, it is increasing in potential energy, but the kinetic energy is slowing. It gets slower, 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 stops with the kinetic for just barely, and then it starts going down, 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 being pulled down by gravity. Its potential is the most here. Its kinetic is the most on the edges. So as gravity pulls it down here, it gets faster, 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 and it is getting less and less potential energy, but greater kinetic energy, because they're sort of two sides of the same thing. As one increases, the other one decreases. All right, so kinetic and potential, you're going to read about that and how it changes. Now, the bottom line with this changes is this thing called the law. So this is not a theory, this is a law, so true it's math. The law of conservation, which is sometimes called the law of conservation of mass, and sometimes it's called the law of conservation of energy, and sometimes it's called the law of conservation of mass and energy. And it says that energy and matter can neither be created or destroyed. Ever since creation, boom, no creating energy or matter. They can only be changed from one form to another, and they can be changed into each other because of E equals mc squared. That's why that formula is so important, why it's so groundbreaking, is because Einstein understood that energy and matter can be transformed one to the other, and we see that in nuclear fusion and fission with this, what is happening on the sun. Hydrogen is being combined into helium. It's called fusion. This is my hand signal for fusion, because I'm pushing the atoms together, causing them to fuse. Fusion. And when that happens, some of that matter gets transformed into energy, and it's why the sun shines. You've always wondered that, right? The other thing is nuclear fission, and that's when big elements like uranium split. And I always tell kids to imagine your hand's a fish and cut it, because fission is not fission, but it sounds kind of like it. Fission is cutting an atom or splitting an atom in half, and it also causes part of that matter to change into energy. So both of those are aspects of the law of conservation. So energy will change. It'll go from electrical energy, then it hits the filament in a light bulb, and it changes to light. Light energy is given off instead. And before that, where the electrical energy came from, it could have been coal burning or something like that, where chemical energy was changed into electricity, or it could be something like we have around here. We have a dam, we have Lake Lanier, and I think it's called the Sydney, I'm not sure of the name of the hydroelectric plant, but we have a hydroelectric plant that changes the energy released from the water falling into electricity. So it's a very green kind of energy. It's very clean because nothing burns. All we do is we let the water fall. It turns a turbine. It's like blowing on a pinwheel. You know what I'm talking about. That little thing you blow it and it turns around and around. When the turbines turn, when the things turn, when the water goes over them, it moves magnets near wires, and that creates electricity. We'll talk more about that later, but a lot of times kids want to go ahead and know how electricity is made. So we talked about the conversion in your car. Chemical energy is changed to mechanical energy as the gasoline is sprayed into the piston of the engine. A spark from the spark plug lights it. It turns it into thermal energy and into an explosion, which pushes the piston down, which turns the crankshaft, which makes the car, which transforms the energy from that chemical energy to mechanical energy, and your car goes. Now, after your car's been going, you go put your hand on the hood. And it's not a Volkswagen or Corvair with the engine in the back. Regular car. What do you notice about the hood? It's warm, isn't it? A lot of the chemical energy that we put in our cars for fuel ends up not in making our car go, but is released as thermal energy. And that's another good point your book makes. It talks about if energy can either be created or destroyed, why is it that, say you're on roller skates and you give yourself a big push and it's totally flat, no matter what, eventually you will stop. You will not go forever. And what stops you is friction. And remember, we learned that friction is these little bumps that are on surfaces, little hills and valleys. They fit into each other and they rub over each other. And when they do, what do you get? Heat, right? Isn't this me rubbing my hands to get warm? Because friction converts mechanical energy into thermal energy. So you won't go on forever with kinetic energy, even though it's conserved. It gets transformed into thermal energy through friction. A lot of our energy is lost through friction. Okay, so we talked about falling objects. It's because of gravity and gravitational potential energy. They fall because gravity pulls on it. And we talked about gravity, what it was, I think, last week. I did in one of the classes I taught. Hopefully it was you. If not, I'm sure we're going to talk about gravity soon, about where it actually, we don't know it really exactly where it comes from, but we do know some things about it, the law of gravity. Okay, so we talked about conservation, we talked about friction, we talked about fission and fusion, we talked about energy in your body. You eat your food, it gets its chemical potential energy, it gets broken down by chemical reactions. There is not a little flame inside of you like a dragon burning up your food. Chemicals burn your food and turn it into energy for you. It gets converted. All right, that is the chapter. Read it, do the homework that you'll find in the description, and like, share, subscribe, and science is great, and come back next time.